Hey folks, welcome back. In this video we're going to go over 4 worked examples to show you how to do problems involving the Bohr model of the atom. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says to explain why quantum physics is required to explain the Bohr model of the atom. Well, the Bohr model of the atom cannot be explained by classical physics. Since electrons in atoms have negative charge, they should emit radiation, lose energy and spiral towards the nucleus. However, we know that this does not happen, so quantum physics must be able to explain it instead. Question 2 says an electron is in the third stable orbit of an atom. Part A says to calculate the angular momentum of the electron. So writing down what we know from the question, we're trying to find the angular momentum L. We know the principal quantum number n is 3 because it's in the third stable orbit. H, Planck's constant, is 6.63 times 10 to the minus 34 jouleseconds. So writing down our equation for the quantization of angular momentum, we have L equals nh over 2 pi. Substituting in the numbers, we have 3 times 6.63 times 10 to the minus 34 divided by 2 pi. And putting that into your calculator gives a final answer of 3.17 times 10 to the minus 34 kilogram meters squared per second. Part B says if the speed of the electron is 1.8 times 10 to the 6 meters per second, calculate the radius of the orbit. Well, writing down what we know from the question, we're trying to find r. We know the mass of the electron m is 9.11 times 10 to the minus 31 kilograms from the datasheet, and the speed v is 1.8 times 10 to the 6 meters per second. Now writing down our equation for the quantization of angular momentum, we have mvr equals nh over 2 pi. And now we can just substitute in the numbers, remembering that we've just calculated this right hand side, nh over 2 pi, in part A. So we've actually got that number, so that will simplify things a wee bit for us. So we can substitute in the numbers to get 9.11 times 10 to the minus 31 times 1.8 times 10 to the 6 times r equals 3.17 times 10 to the minus 34, which was our answer from before. So now I would do the left hand side in your calculator and then divide 3.17 times 10 to the minus 34 by your answer to get r on its own. So we have r equals 1.9 times 10 to the minus 10 meters. Question 3 says an electron in the second stable orbit around a hydrogen nucleus has a linear speed of 1.1 times 10 to the 6 meters per second. Calculate the circumference of this orbit. Well, writing down what we know from the question, we're trying to find circumference, which is equal to 2 pi times the radius, 2 pi r. We know that m, the mass, is 9.11 times 10 to the minus 31 kilograms for an electron from the datasheet. V, the speed, is 1.1 times 10 to the 6 meters per second, and n equals 2 because we're in the second stable orbit. We then have Planck's constant h, which is 6.63 times 10 to the minus 34 jouleseconds, again from the datasheet, and writing down our equation, we have mvr equals nh over 2 pi. So what I'm going to do now is rearrange these terms to get 2 pi r on its own. So notice how I've got r on the left, but I've got 2 pi on the bottom of the fraction on the right. So I'm simply going to cross multiply and put 2 pi up here, but then divide again by mv. So I'm going to end up with 2 pi r equals nh over mv. So it's almost the same as swapping the 2 pi round with the mv. So now all I need to do is sub in my numbers to find what nh over mv is, and that will be me calculating the circumference 2 pi r. So we can sub in 2 times 6.63 times 10 to the minus 34 divided by 9.11 times 10 to the minus 31 times 1.1 times 10 to the 6. And if you put all of that into your calculator, you should get an answer of 1.3 times 10 to the minus 9 meters. Lastly, question 4 says to calculate the velocity of an electron in the first Bohr orbit with a radius of 5.3 times 10 to the minus 11 meters of a hydrogen atom. So writing down what we know from the question, we're trying to find the velocity v. We know that the mass of the electron is 9.11 times 10 to the minus 31 kilograms from the datasheet. The radius r is 5.3 times 10 to the minus 11 meters. N equals 1 because we're talking about the first Bohr orbit. And Planck's constant h equals 6.63 times 10 to the minus 34 jouleseconds from the datasheet. So writing down our equation, we have mvr equals nh over 2 pi. Remember, we're trying to calculate v, so let's just sub in the numbers and then try and find v on its own. So we've got 9.11 times 10 to the minus 31 times v times 5.3 times 10 to the minus 11 is equal to 1 times 6.63 times 10 to the minus 34 over 2 pi. So I would do the right hand side in your calculator first and then divide by this term times this term to get v on its own. And if you put that into your calculator, you should get an answer of v equals 2.2 times 10 to the 6 meters per second. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.